I've been asked to go over the code in PrimeNumber. There are 2 or 3 different ways you can write this program. I'm going to start out with the simplest way, and that is to just write a loop in main that is going to check to see if a number can be evenly divided by any number other than itself or 1. Don't overthink this one. A lot of the solution to this is more math knowledge than it is programming. So here's what we know about prime numbers. A number is prime if it can only be evenly divided by itself or 1. We know that every integer can be evenly divided by 1. We know that every integer can be evenly divided by itself. We're looking for numbers between 1 and the number in question, and we're going to see if any of those numbers can evenly divide into the number in question, the number that we're checking. So for example, we know 3 is a prime number. If I wanted to test 3 just to verify that it's prime, I would say, well, I know that 3 divided by 1, that comes back with a remainder of 0 because 3 is evenly divisible by 1. 3 is evenly divisible by 3 because 3 divided by 3, while the answer is 1, the remainder is 0. If I divide 3 by 2, the answer is 1, but I get back a remainder of 1. It is not evenly divisible by 2, so it is a true prime number. It can only be divided by 1 and itself evenly. When I'm checking for a prime number, I'm not dividing it by numbers higher than itself. So when I'm checking to see if 3 is prime, I'm not going to divide it by 4, 5, 6, 7, and so on. And I don't need to verify that it's evenly divisible by 1 in itself. We know that's the definition of prime. So I'm only checking the numbers from 2 right up to whatever that number is to see if it's evenly divisible. Now we know that we can tell if the remainder is 0 or not by using the mod operator, the percent sign. So we're going to write a loop that's going to take whatever number we're checking, and it's going to divide it one at a time by every number from 2 up to that number, and we're going to check the remainder. Now I'm going to do this in main. Like I said, there's 3 or 4 different ways to do this, but the simplest way is just to do it in main. And I'm setting up a Boolean value. Booleans, remember, can only be true or false. Notice I do not put quotes around the word true, and as soon as I type the word true, it turns blue to indicate it's a special keyword. If I wanted to type false there, I would do the same thing, no quotes. It's easiest to say, let's assume every number is prime, and when we're looping, the second we find a number that has a divisor other than itself or 1, where it's evenly divisible, we can flip that is prime to false. We know we don't have a prime number anymore. So I'm going to start out checking the number 5. And of course, if you know how to use scanner, you can get the input from the keyboard. I'm going to write a for loop. I'm going to have my counter, and I'm starting at 2. Remember, I already know 5 is evenly divisible by 1. I don't need to check that. I'm trying to find other numbers by which it is evenly divisible. And I want to loop as long as the value in my counter is less than the number I'm checking. Again, I want to divide 5 by 2, by 3, by 4. But I want to stop at 4. I don't need to check to see if 5 is evenly divisible by 5. I know it is. That's not part of what I'm checking. I'm trying to find a number that will divide it evenly other than 1 or 5. And I'm going to bump my counter up by 1. So my counter is going to go 2 to 3 to 4. And each time I'm going to divide that number into 5, and I'm going to check my remainder. And just to prove, so you can see how the loop works, I'm just going to print out my counter each time so you can get the idea of exactly how this thing is working. So now I'm going to put an if statement in. If my number divided by my counter if the remainder of that is 0. So if I were doing my straight division, right, I would use the division sign. I would say 5 divided by 2 is 0, but I don't care for the answer. I want the remainder. So instead of putting the slash for division, I'm putting the percent. So what that's going to do is it's going to divide 5 by 2. Doesn't care that the answer is 2, but what it's going to tell me is the remainder is 1, so the remainder is not a 0. That means it's not evenly divisible. Well, I'm looking for the situation where the number I'm checking is evenly divisible by something other than itself or 1. So if that's the case, if I divide 5 by 2 or 3 or 4, and the remainder comes back as 0, meaning it was evenly divisible, I'm going to flip my prime to false. So I know I no longer have a prime number. But if my number were 4, for example, I would come in, 4 divided by 2, the remainder would in fact be 0. It's evenly divisible, and I would know I did not have a prime number. Then outside of the loop, once the loop is done, I'm going to say if is prime is true, I'm going to say my number is prime. Otherwise, my number is not prime. Okay, so now I'm going to run this. It's going to check the number 5. We're going to watch the loop go through from 2 to 3 to 4. It's going to divide 5 by that number every time. And it's going to come back and tell me, in fact, that 5 is prime because no number between 2 and 3 and 4 will evenly divide into 5. Now if I change this number to 6, it's going to check it. It's going to divide it by 2. That's going to be a remainder of 0. It's going to know that, in fact, 6 is not prime. It's going to flip that to false. Now, I don't have a way at this point to stop the loop. So it's even though once it divides it by 2, we know it's prime. In theory, we should be able to stop the loop. There's no sense checking if it's evenly divisible by 3 or anything else, because once we find that 2, we know it's prime. But at this point, we don't have a way to stop the loop. But setting it up like this will make sure we will still get the correct answer. Okay, so that is the simplest way to do it. Now, my understanding is that one of the rules for finding prime numbers, whether a number is prime or not, say you had the number 624, and you don't want this thing to have to loop all of that time. My understanding is that one of the rules for prime is you can check all the numbers from 2 up to the square root of that prime number. And again, that's more of a math knowledge thing than a programming. So in the math library, we have a square root function. So in theory, for those of you who are more advanced programmers, if you wanted to, you could shorten the length of time that your loop's going to execute by saying loop from 2 until whatever the square root of the number is. So if the number was 25, I take the square root, that would become 5, and I would loop 2, 3, and 4, and that would tell me whether or not it's prime. I don't have to keep going all the way up to 25 to check it. Again, if you're an advanced programmer and you want to do that, that's fine. But if you're a beginner and you just want to let it go the extra times to loop, that's fine as well. Now, I don't want this to go longer than 15 minutes, and I'm starting to run out of time. But let me see if I can show you maybe a better way to do this as a completely new project. We'll call this Prime Tester, and we'll actually maybe write a little class file. Instead of doing it in main, I'm going to create a new class file. I'm going to call it Prime, and I'm going to come in here, set up an instance variable, And here's my constructor. And I'm going to set my instance variable equal to that parameter that I passed in. And maybe I'm going to write a little isPrime function here. And I can put the code that I had in that other one in here. Something like this. I've got my counter. Let me change this to isPrimeNum. I can set up a Boolean here. Here's my isPrime. So now I've kind of broken it out into the traditional way that we've been doing things, with the idea of having a method here that's going to check and see if it's prime. Then I can come over here and I'm going to send it the number 5, for example. And then I can call it something like that. Now, I'm running out of time. This isn't the best as far as output. I just kind of wanted you to see that you could come in here, you could set up your constructor, pass the number in, run everything through here, and return that back. Okay. And then here you could print out true or false, something like that. So again, you could make this better. You could maybe have the output be a little better. You could do your print lines in here, make this a void, actually go ahead do your print here, and then over here you'd make this a little different. You could just do something like that. So that's another option. The other thing I wanted to show you is that with Booleans you can take a little shortcut. When it's true, instead of having to type equal equal true, if you just put if is prime, that is the equivalent as if you had typed is true. When you put if is prime, it will check to see if it is true. So that's another thing in your if statement. You can't do that here where you're setting the value. Obviously you have to put false or true to set the value. But in an if statement, in the condition, if you want to check to see if something's true, you can just take a shortcut. Instead of putting the equal equal true, if you just use the Boolean variable name, the compiler interprets that as if you said if is prime is true. So that's another little shortcut you can take there. For those who are more advanced, you could act, and if you're a beginner, ignore this, but if you're advanced, you could really shortcut the loop by turning this back into a return with a Boolean, and then once it finds the first number, you could in effect return false. Otherwise, instead of doing this if, you could return true, and then kind of do your output in the other method. But again, that's only for advanced programmers. If you're a beginner, either do it all in main or do the very simplified version that I showed you here. But again, don't overthink this. It's actually kind of simple, and it's more math knowledge than programming.